cosmic firework display we will witness a spectacle that only happens once every 1,000 years. The last supernova that was visible on Earth completely misled people. This time we are better prepared, but even our best scientists don't know for sure what will happen. Are we really out of the danger zone, and what will happen to Earth when the supernova bombards us with myriads of neutrinos? Let me tell you a story about a star that shines so brightly in the night sky that it has served as an inspiration and guiding star for generations of people. Betelgeuse, the shining jewel in the constellation Orion, has been one of the brightest stars for thousands of years. What our ancestors did not know is that this star is so unusually large and glowing red. Because it's a star in the last phase of its life, Betelgeuse probably slowly inflated into a red supergiant 100,000 years ago or more. Its fate has been clear ever since. It will meet a spectacular end as a supernova, fascinating not only astronomers but also laymen worldwide. Thanks to advances in telescope technology and astrophysics, we can now be up close and personal with all the events on the red supergiant star. Astronomers monitor Betelgeuse around the clock as its explosion could be imminent. Every change, no matter how small, is registered, and the star has recently given cause for Betelgeuse concern. Betelgeuse is more than just a star. Did you know that hardly any other star has as many names as Betelgeuse over the centuries? Betelgeuse has fascinated astronomers and stargazers alike. Its conspicuous position in the constellation of Orion and its visible redness have made it an integral part of sky observation. The unusual name comes from the Arabic Bit al-Hota, which means house of the twin. Later it became Yed al-Hota, which means hand of Orion, and finally the name Betelgeuse prevail in Bayer's Latin list of stars. It is called Alpha Orionis. Alpha Orionis means that Betelgeuse was regarded as the brightest star in the constellation Orion. The Persians referred to the large red star as one of the four royal stars or guardians of the sky, and the Chinese called Betelgeuse Shenu Si, which means the fourth of Orion's belt for the ancient Egyptians. Betelgeuse symbolized immortality and was part of their constellations associated with life after death. For the Aborigines in Australia, Betelgeuse is an important part of their spiritual creation story. For astronomers, it's the brilliant red supergiant that adorns the constellation Orion, with a diameter more than 1,000 times that of our Sun. Betelgeuse would reach the orbit of Jupiter if it were placed in the center of our solar system. This immense size not only gives it an impressive luminosity but naturally also makes it a particularly interesting object of study. Never before have researchers been able to witness the end of a star's life directly. Betelgeuse is in its late phase, characterized by a massive expansion that began after it had consumed most of its hydrogen as a red supergiant. It is well on its way to ending its life in a spectacular explosion supernova in the not-so-distant future. This event will show us the complexity and beauty of the universe in a unique way. Supernovae around the Earth are rare and offer astronomers a rare opportunity to study the dynamics of the explosion and the birth of new elements. Exploding stars hurl large quantities of material into the universe, which is then dispersed ever more finely, forming new clouds of gas and dust in other places and giving rise to new stars. Of course, our ancestors were unaware of all these processes. When Johann Kepler observed the supernova in 1604, he wrote ecstatically in his diary, "I did not feel able to let such an extraordinary phenomenon pass without careful observation." Kepler did not observe the explosion itself, but he saw the glistening bright spot of light that was suddenly visible in the night sky and described the object as a new star in the constellation of the Serpent Bearer. Supernova means great new star, and this term was actually a misunderstanding. Nobody knew at the time that the light was just the afterglow of a star's death, so Kepler's new star suddenly disappeared after a few weeks, which rather confused the astronomers. Chinese astronomers had witnessed the supernova and described how a bright glow could be seen on Earth. Today's researchers reconstructed that the supernova SN64 reached a maximum brightness of about -2.5 magnitudes, making it the brightest object in the night sky next to the Great Concern for Betelgeuse Moon. Great Concern for Betelgeuse. You may be surprised to learn that researchers have been meticulously recording every small change in Betelgeuse's brightness for decades and compiling it into a kind of map. They noticed 2 cycles of dimming, also known as dimming. In 2019, the red giant star suddenly showed unusual fluctuations and brightness which caught the world's attention. The phenomenon known as great dimming was already seen by some as a sign that Betelgeuse was about to perform its final act, but then everything changed. The unusual change led to a wealth of research and theories. Eventually it was discovered that a massive dust cloud emitted by the star itself was responsible for the dimming. Betelgeuse had experienced a kind of mass ejection as we know it from our Sun, only the dimensions of this enormous star were completely different. The Great Dimming was also jokingly referred to as the coughing of an old star for scientists. The unusual spectacle was a testimony to the turbulent processes that take place in the last phases of a star's life on the direct path to supernova. Its explosion is inevitable, and researchers have already calculated several times when we should expect the spectacular end of the star. Scientists have repeatedly come up with astonishingly different results. A Japanese research group only presented a new paper in 2023 according to which the explosion must take place much earlier than previously assumed. Previously, astronomers had given the event a wide range from a few years to 100,000 years. Thanks to modern telescopes, we have already been able to observe a number of supernovae far away in the universe. As a result, researchers already know a lot about what happened in the final stages, but they cannot know everything. No two stars are exactly alike, and Betelgeuse is not just any star in practical terms. This means that we do not know when the star will explode or whether it has possibly already exploded. Betelgeuse is 548 light-years away from us. We therefore see the star as it looked 548 years ago. If it explodes, it will take 548 years for its light to reach us and for us to see the supernova. Until then, researchers have reconstructed the final processes using complex simulations of the processes inside the star. After using up most of its hydrogen, Betelgeuse has become a red supergiant. Since then, the star has inflated and its outer shell has cooled, giving it its characteristic red color. Further feverish processes are constantly taking place in the core of Betelgeuse. After the hydrogen has been consumed, the star begins to fuse heavier elements. The process starts with helium, which is fused into carbon, and continues with heavier and heavier elements until iron is reached. However, iron fusion consumes energy instead of producing it, which destabilizes the star even further. In addition, iron is heavy. These effects eventually lead to core collapse and the explosion of the outer shell. The harbingers of the explosion will most likely be further dramatic changes in brightness. However, we are not safe from surprises and must expect the star to burn up without any further warnings or signs. After the explosion, Betelgeuse will probably be left as a neutron star or black hole, while the outer layers of the star will be ejected into interstellar space. This matter will become part of the cosmic building blocks for new stars, planets, and perhaps even life. Researchers believe that the first signs measurable on Earth will be significant in increases in neutrinos. These particles are sun